Okay, so we will talk about log today, logarithmic function today. Okay, so first the definition of log. Okay, so let's say we have log a of b is c. Okay, log a of b is c. So there are three parts. Okay, there are three parts. So this part is the base. Okay, and then c is the exponent, and then b is the power. Okay, so it's very hard to remember the order in this way and the meaning in this way. So the most important thing is A is the base. Okay, A is the base. So let's delete B and C. Okay, A is the base. So every time we start from the base. Okay, we start from the base. So what's the relation between log and exponents? Okay, log and exponents. So log a of b is c if and only if a to the c's power is b. Okay, is b. Still, this is too hard to remember, right? This is too hard to remember. So I made a circle. Okay, I made a counterclockwise circle. Sometimes it's clockwise. So to change log to exponential form. Okay, so this part is the log form. This part is the exponential form. Okay, exponential form. So let's look at this circle. Okay, this circle. So always start from the base. Okay, so a to the c is b. Okay, so when you rate it, a to the c's power is b. Okay, is b. So now if you reverse, if c is log a of b, right? A of b. So again, we start from the base. And then draw a circle, right? Draw a circle. So the circle has to be this way, right? From A to C, C to B. Okay, C to B. Always start from A. Okay, start from A and then to the other side of the equation. Okay, to the other side of the equation. So now it still give us A to the C's power is B. Okay, is B. So now let's practice this thing a lot of times. Okay, a lot of times. So first let's say log 2 of 8 is 3. Okay, log 2 of 8 is 3. So how can we change this to exponential form, right? So this part is log form, this part is the exponential form. So base is 2. Here is the base. So start from the base. So we got 2 to the third power is 8. Okay, so this means 2 cubed is 8. Okay, so 2 to the third power, so 2, 3, and then to 8. That's the circle. 2, 3, 8. Okay, 2, 3, 8. 2 to the third power is 8. Okay, yeah. So now, if this is log 3 of 9 is 2, so this is equivalent to from the base, and then goes to the other side of the equation. 3 to the second power is 9. Okay, is 9. So 3 squared is 9. Okay, 3 squared is 9. Okay, so you always can change log to exponent or exponent to log. Okay, exponent to log. Okay, yeah. So now let's try to change exponent to log, right? So if you have 5 squared is 25. Okay, how to get the log part? Okay, how to get the log part? So first you write down the bases here. Okay, here is the base. So in the exponential form, base is 5, so this is 5. And write down equal sign, so 5 go to the other side. Okay, base and then to the other side. So 5 squared is 25, so we have 5 to the other side, so squared. Two is here, okay, and then is 25. So 25 is inside the log on the left of the equation. okay, of the equal sign. So 5 squared is 2. Okay, 5 squared is 2. So let's try this again. So suppose we have 2 to the 5th power. So this is 32. Change this to log. So log, first we write down base 2. Okay, base 2. And then go the other side, 2 to the 5th. So this is 5. Okay, and then go back, finish the circle. So this is 32. Okay, 32. So 2 to the 5th power is 32. So that side, this is all the exponential form, and these are all the log form. Okay, these are all the log form. Okay, so this is the definition. So now let's try to solve some questions. Okay, so let's try to solve some problems. Okay, so this is number 2 in the webwork. So I'm going to do the A part and then leave the B part to you. Okay, leave the B part to you. So let's write down this log again. Log 32 of 2 is 1 over 5. Okay, is 1 over 5. So now let's draw the circle. So from the base to the other side of the equation, and then go back to number 2. Okay, so the corresponding exponential form should be 32 to the 1 over 5's power is 2. Okay, is 2. So what's the ABC here? So A should be 32, B is 1 over 5, and C is 2. Okay, C is 2. So the only thing you need is the definition. Okay, is the definition. So next example. Okay, so let's look at problem 4 in the 10.5. Okay, in the 10.5. So now you look at this notation. Okay, this notation. So log D is equal to E. Okay, is equal to E. So where's the base? Okay, where's the base? So there's no base here. By assumption, we assume base is 10. Okay, base is 10. So this is called common log. Common log means no base, so which is equivalent to base is 10. Okay, base is 10. So you can add the base 10 here, okay, and then we do the circle, right? Then we do the circle. So 10 to the E's power is D, okay, and then you can answer the question, what is D, what is G? Okay, what is D? So here we learned a new thing. It's called common log. So there's no base in this log notation, which means base is 10. Okay, base is 10. So another special notation is called the natural log. Okay, the natural log. The natural log means the base is E. Okay, the base is E. So what's this number E? Number E is something bigger than 2. Okay, something bigger than 2. Okay, so here E is irrational number, so it's about 2.71828, and there are a lot of digits after this number 8. Okay, so E is about 2.7. Okay, E is about 2.7. So now by assumption, so this is called natural log. Natural log means log with base E of any A, so this will be ln A. Okay, ln A. So natural log means log with base E, and we don't want to write down log E, so we just use ln, stand for log E. Okay, stand for log E. So log with base E, and then something is equivalent to ln something. Okay, ln something. So for this problem 6, first you have to change this ln, natural log, to log E, and then you put C is equal to D, right? And then you draw my circle. E to that power is C. Okay, is C. So E to the D's power is C. So here we got C is X and D is 5. Because E to the X is 5 here. Okay, so this is E to the X is 5. So you compare this. So C is 5. D is X. Okay, D is X. So we have these two special case for the base. Base 10 is the natural common log. You can skip that, you can delete that. Without base means base 10. And natural log means base E. So we use ln for natural log, okay, for natural log. So these are our two special base, okay, two special base. So now let's solve some questions, solve some x, okay, solve some x. Okay, so here again, I'm going to solve the A part, and you can try to copy my A part to solve the B part, okay? So here the A part, we got log x of 9 is 2, okay, is 2. So it looks like a very hard question, so now let's change it to exponential form. Draw my circle, right? So we get x squared is 9. So what number squared is 9? X is 3, okay, x is 3. So some students may say, okay, so we may have -3 as the answer. So there is a very important definition for the log. Everything we assume is positive. The base is positive. Okay, the base has to be positive, then the power is positive. Okay, yeah, so if you have log A of B, so the assumption A is positive and B is positive. Okay, B is positive. Okay, only the number on the other side could be positive, negative, rational, or irrational. Okay, so this question is just an application of the definition. Okay, definition. Okay, so now the new question, part A of problem 5, right? Problem 5. So what is this question? So log 6 of x is 2. Okay, is 2. So again, use the circle. 6 squared is x. Right? We change to exponential form. 6 squared is x. So 36 is x. Okay, so x is 36. So if you know how to use the circle notation, change the log to exponent, this part is very easy. Okay, this part is very easy. So for math 6, basically we just change log to exponent and then solve the question. Log form to exponent form to solve the question. In math 30, you will learn some other properties and solve other harder log equations. Okay, log equations. So next one. Okay, so number 7 has a lot of questions. Okay, it has a lot of questions, so I'm going to solve the first two. Okay, I'm going to solve the first two, the easier part. So the idea is we will use this relation between log form and the exponential form to solve it. Okay, yeah. So we will assume the unknown, the answer is x. Okay, is x. So first question, log 5 of 25 is x, right? So use the circle. So that means 5 to the x power is 25. 25 is what? 5 squared. So 5 to the x is 5 squared. So x is 2. Okay? So this part is what we learned last time. How to solve an exponential equation. Right? We change both sides to the same base and then solve it. Okay? Solve it. Okay, so now we can use this idea. You change log to exponential equation and then solve it. Okay, and then solve it. The next one, right? The next one. So log 6 of 36 is x, right? So 6 to the x is 36. 6 to the x is 36. So 6 to the x is 6 squared. 36 is 6 squared, right? So x is 2. Okay, x is 2. So I got the same solution number 2 for the first two problems. Okay, you can try other problems. They're very similar. Okay, they're very similar. Okay, so there's number 9 is a little bit harder, but the harder part is the exponential equation part, right? So we want to solve this log 2 of 1 over 32. Okay, 1 over 32. So again, we assume this is x. The answer is x. Okay, we need two sides in the log notation and then change it to exponential form. So 2 to the x will be 1 over 32, right? So that's the exponential form. 2 to the x power is 1 over 32. So now is the exponential equation, right? So we need change 1 over 32 to base 2. So 1 over that means negative. So 2 to the negative 1, 1 over 2. 2 to the negative 2, 1 over 4. You can just use listing method until you get 1 over 32. 2 to the negative 4, 1 over 16 is closer and closer. 2 to the negative 5 is 1 over 32. Okay, you just list it and then you got this is 2 to the negative 5's power. So drop the common base, we got x is negative 5. Okay, x is negative 5. Okay, so this is harder because the answer is negative. Okay, the answer is negative. The last question. Okay, the last question. So basically, we just know the definition of log. Okay, definition of log. Okay, so the last question, we have a rational number here. We have a rational number here. So let me rewrite it. Log 9 of x is 3 over 2. Okay, 3 over 2. So again, use our circle. 9 to the 2/3, 3 over 2's power is x. So 9 to the 3 over 2's power is x. So now how to find this rational power? Use roots and powers, right? So this means square root of 9 and then cubed is x. So square root of 9 is 3, so 3 cubed is x. So 27 is x. Okay, 27 is x. So this is almost the only thing we learned today. Okay, we learned today the definition of log. Use the circle. Okay, use the circle. So remember, okay, remember the rule is not counterclockwise or clockwise circle. It's always start from the base. If you put 3 over 2 on this side, so start from the base, 9, go to the other side of the equation. Okay, equal sign. And then go back. Okay, and then go back. So this one, this circle is clockwise and this circle is counterclockwise. Okay, so from the base to the other side and then go back. Okay, and then go back. So that's the definition of log, how to change log to exponential form. Okay, yeah, so that's it. That's our today's lecture.